Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have square root of k is equals to minus k, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem from first method. In the first method here, we need to remove the square root sign from left hand side, and for this we will take squaring on both of the sides, and when we apply squaring it will be written as square root of k and its whole square equals to minus k whole square. And now you see here this 2 and this square root are gone, and we will get here k is equals to, this is minus k whole square, and we have minus k square becomes plus k square, because we know about that when we apply square on negative term it will becomes positive. And further we move this k from left hand side to the right hand side, and it will becomes k square minus k, and this whole equation is equals to 0. And now here further in the next step we need to here we need to take common k, and when we take common k we get the remaining values are k times of k minus 1, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write k equals to 0, and the second case is we write k minus 1 equals to 0. So this is the first root of the given equation, and from here we get the value of k is equals to plus 1, and this is the second root of the given equation. So here we obtain these are the two roots of the given equation. And now here in the next step we need to verify that which of the roots are solution and which of the roots are extraneous root. So for verification of these roots we need to copy down given question statement. Here it is square root of k equals to minus k, and now here in this side we will be verify k equals to 0, and in this side we will be verify k equals to plus 1. So here first we verify k equals to 0, and when we put k equals to 0 on both of the sides it will be written as square root of 0 is equals to minus 0, and we easily get 0 equals to 0. This shows that both of the sides are equal, and if both of the sides are equal this means that the value of k equals to 0 is satisfied our given question statement. And now here in the same pattern we verify the second value of k, and we put this value of k on both of the sides, and it will be written as square root of 1 is equals to minus 1, and we clearly see here this is 1 is equals to minus 1. This shows that both of the sides are not equal, and if both of the sides are not equal this means that the value of k equals to 1 is not satisfied our given question statement, so we call that k equals to 1 be the extraneous root of the given equation. So k equals to 1 be the extraneous root, and because k equals to 0 is satisfied our given question statement, so we call that k equals to 0 be the solution set of the given equation. So this is our final answer which we get here from first method, and now here we again solve this problem for second method. And now here for the second method we first need to copy down given question statement here, so that our given question statement is square root of k is equals to minus k. So this is our given question statement, and here in the second method we give another technique to solve this problem for the values of k. So here we move minus k to the left hand side, and it will be written as square root of k plus k is equals to 0. And here here we use this nice rule of radicals. You know about that if we have any number x, we write this x as in the form of product of two radicals. Okay, we write this x as square root of x multiplied by square root of x. Okay, in the same pattern according to this rule we write our this k as in this form So we write it as square root of k, plus we write this term as square root of k multiplied by square root of k, and this whole equation is equals to 0. And now here in the next step, we need to take common square root of k from here, and when we take common square root of k, we get the remaining values r. So from here we get 1, plus from here we get square root of k, and this whole equation is equals to 0. And now in the next step, we divide this equation into the two cases. The first case is we write square root of k equals to 0, and the second case is we write 1 plus square root of k is equals to 0. And now here first we copy down both of these two terms here. This is square root of k equals to 0, and here we have 1 plus square root of k equals to 0. So for the values of k, from here we need to take squaring on both of the sides, and when we apply squaring, it will be written as in this form. These two and square root are gone, and we easily get the value of k equals to 0. From here we move plus 1 to the right hand side, and it will becomes square root of k is equals to minus 1. And here we again take squaring on both of the sides. It will become this 2 and square root are gone, and we get here k equals to minus 1 square becomes here plus 1. So in the second method, we again get these are the two roots of the given equation, but in the first method, we already verified that k equals to 0 be the solution and k equals to 1 be the extraneous root. So we write it here, k equals to 1 be the extraneous root because it does not satisfy our given question statement. And k equals to 0 satisfied our given question statement, so we call that k equals to 0 be the only one solution set of the given equation. So this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.